Hello viewers, welcome back to the lab. It's now 2020 and it's time for a teardown. So a few of you might recognise what this is. This is a Theodolite. This is one that dates from mid-1980s. I saw this on eBay and thought, yeah, it could be interesting because it's electronic. So I'm figuring that there's going to be some electromechanical goodness which might be interesting to see when we do a teardown. So I'd like to thank my patrons who helped support this channel, allowing me some funds to buy things like this so we can take them to bits. If you want to become a patron yourself and help the cause, then there will be links up in the top corner there and in the video description. So a Theodolite is an angle finder. It measures at a basic level horizontal angle and vertical. Now distance is also really important, and this one doesn't do distance, but it can be upgraded to do distance using an EDM, electronic distance measuring device, which clips on the top here. I don't have that. So this is actually manufactured by Wild Heerbrugg, and it's a Theomat Wild T2000, dates from around about 1986. It's Swiss made, so it obviously it's been put together really well. There's lots of really nice engineering in this, so it should be interesting on the inside. No idea what these would have cost back in the day. I would have said, given it is Swiss and particularly high quality, probably quite a lot of money. I guess tens of thousands. Not really sure. If anybody knows, let me know. In terms of the condition of this, it looks like it's been dropped. To be honest, we've got a missing knob on the side here, and that is actually also slightly bent. Missing the battery cover, so that's gone missing. And this piece here, which is the optical plumb line, this looks bent as well. So I think it's been dropped. So the chances of this being usable is probably pretty slim. It's probably well out of cal. But it does appear to work. I have actually connected this up and it does seem to work, so I do feel a little bit guilty about taking it apart, but I've never seen the insides of one of these at all, not on YouTube, so this one could be a bit of a first. So the typical operation for this would be to install this onto a tripod, and you align the centre of this with a point in the ground. And then you can take the measurements from there. There's lots of turn this over. So we've got adjustments for getting the level right, and there is also a hole through there. That's optical, so you can actually see from through here. This is actually an eyepiece. You can look through here, and that gives you visibility down out the bottom there to accurately align up with the point on the ground through the tripod. We've got some analog scales on the base here with a little window, which you can just see in there, possibly. The whole thing's pretty heavy, probably weighs about 8 kilos. It's a fair bit of weight to it. Obviously it's all metal, it's all designed to be used outdoors, very rugged. It all seems to be aluminium, I would say. In the centre here we've got the small telescope, which allows you to align up with the remote marker point. So we've got diopter adjustment on the front there for your own vision, and we have a focus control for the actual scope part. As I said, we've got a mounting point on the top here. This would have been used for the distance measuring unit, which would have plugged on there and made contact with those pins just in here. I believe there's a couple of different versions of that, one of which plugs into a small little socket, little LEMO connector on the side here, so there would have been a little wire. We've got adjustment knobs on the side here. These are basically for operating the vertical and horizontal alignment, so once you've got it roughly in place, you lock with this knob here, and then that's locked in place, and then you have a vernier control, and the same with the eyepiece. You can just lock that into place, and that locks this, and then the knob that would have been on here would then adjust the angle of this very precisely. Battery would have gone in here. This was probably a rechargeable, probably nickel cadmium back in the day, 12 volts I believe. So I've just got some wires soldered onto the terminal so I can actually power this up. On the top here we've got a really nice machined carrying handle with some nicely machined little clips, some really nice machining attention to detail in there. On the front here we've got a small control panel, really nice little clicky buttons. I guess this is all going to be waterproof, so you can use this outdoors. Right, so we've powered this up on my bench power supply, so I'm just putting on 12 volts into it, and press the on button. Turns on, whirs away for a second or two, and then gives us two readings. One is the horizontal and one's the vertical. Now at the moment that's just done a single read and then stopped, but I can actually have this going in a continuous mode. So if I adjust, this is the horizontal, so you can see there I'm at 199.74810 degrees, and as I adjust this you can see the number changing there, and it's really fine adjustment on this, and it actually helps if you don't touch it. You notice there that the vertical reading, let's just, as you can see, so the vertical reading, you can see that actually fluctuates around a little bit. If I start tapping it, it does affect the reading quite a bit, so yeah, obviously quite a sensitive bit of kit. Now I'm sure there's going to be all sorts of things you can do with this. I'm not going to go and try and find out how to work this, because it's probably really complicated. But there does appear to be a lot of different functions in this for working out various different things. And yeah, not much in there. I was just taking the side panel off here. It's cast aluminium, or possibly magnesium. Some nice gaskets and stuff in there, some nicely machined edges in there. I've just noticed there's a little white dot that would probably indicate the axis through the telescope part. Right, so this all looks really interesting in here. We have a wheel here which is driven by a motor with a small belt. There is a glass ring on the outside. I can just about see some markings on it, so there's definitely a grating on that glass ring going around the outside. We have some optical sensors here, and is there any underneath? I can't quite see. Does look like there's something underneath there. We've got this arrangement at the top with two optical sensors in. I can't really see where that's going. There's a lot of wires connecting up here onto a slip ring assembly on here, which makes connections through to the actual telescope part. I can just see it moving there on the centre. If we just look into the battery compartment, we do actually have something protecting something in there. There's a piece of plastic, looks like it's some kind of tube, which runs into this section and then up into here. Oh, I think I see what it is. It's where the wires go. Yeah, the wires run through this down into this section. This bit here, which is the adjustment for the optical plumb line, so you can see the point on the ground. That does look like it's been bent. There's definitely some broken plastic on there. So yeah, unfortunately it looks like it's had some kind of damage on it. Looks like we've got a stack of 3 PCBs in here. All old school through-hole stuff, as you'd expect given its age. Date codes, 85, 85, 84, 84, 83. So yeah, probably about 1985, 1986 vintage. There's lots of nice little detail on these adjustment knobs, lots of slip rings, O-rings. So that O-ring would sit inside this lip here, and that's on a slip ring. So it, yeah, there's a lot of time and effort being put into that. Interesting that the PCBs aren't conformal coated. I thought they might have been, given that this is going to be used outside, but yeah, they just look like just plain old PCBs. So I think I'm just going to remove these boards out. Looks like they're just held in with these locking nuts. So before we take a look at these PCBs, I want to thank my sponsor PCBWay for their continued support. If you're a hobbyist or professional and need fast turnaround, high quality PCBs made, then you really need to check out and try PCBWay. They can manufacture just about any kind of PCB you might need and always have tons of offers and coupons on for new and existing users. So I can highly recommend you go check them out. Links will be in the video description. Right, let's have a look at the circuit boards. This is quite clearly the main CPU. We've got 2 EEPROMs on here. Those are both 27C64. We have an Oki M80C85, which is a microcontroller with some RAM on it, and we have this device here, which is Intel D8741. So yeah, that's probably yes, that's a 8-bit microcomputer with EEPROM. So you can completely reprogram this by erasing and then reprogramming it if you have the right tools to program it. We have 8-bit CPU plus ROM, RAM, I/O, timer, clock, DMA, interrupts. We have 8K of EEPROM, 64 bytes of RAM, 8-bit timers, 8-bit programmable I/O pins. Sorry, 18 programmable I/O pins. Runs at 3.6 megahertz. Yeah, nice little UV erasable microcontroller there. There's a couple of Toshiba memory parts on here. TC5047AP-1, and they are 1024 word by 4-bit. So those are only 4-bit CMOS RAM. So that gives us 512 bytes in total. And that's pretty much it. There's a battery on here. I wonder if there's any charge left in that. Yes, there is. 2.7 volts. Now, one thing that I have noticed on this board is a really weird PCB material. It feels velvety, and the traces seem to cross each other. I'm not sure whether you can really see that on camera. See if I can zoom you in. It's almost like they're woven. It looks really odd. It also marks really easily. Yeah, if you look at, if I get my magnifying glass on the edge of this, you can see that there's an inner layer, 2 green outer layers, and then this sort of olive green layer on top. It's really, really strange. I've never seen anything quite like it before. This writing here looks like it's underneath something. So yeah, I've never seen anything like that. Okay, the next board to look at is the power board. I think this was called power board. Yeah. So obviously this will do all the power regulation, things like that. We'll have the looks like we've got the battery coming into a DC to DC converter, which is enormous. I guess these things have definitely shrunk over the years. So we've got 12 volts in and 5 volts out. So yeah, given that's a 12 volts in, 5 out, that is enormously large package there for a DC-DC converter. We've got some 12 volt relays, another one, some big old tantalum caps there, and various connectors that went out to the bits on the other boards. So yeah, not a lot to speak of on there. And this is called angle board, so this will be the one taking the inputs from all those sensors and turning it into something that the CPU board can actually process. We've got another one of those programmable microcontrollers, that the UV erasable ones, a load of logic stuff going on. We've got some hybrid modules, which looks like they went out to the sensors, so a couple of bodge wires on there, not surprising for a low volume product like this. And that is a D8741AD 8-bit microcomputer, which is UV erasable, 8-bit CPU, 1K of ROM, 64 bytes RAM, timers, etc, etc. Right, so I'm not sure what that knob was doing, but it does something. I wonder whether it's the backlight on the LCD panel. There is a backlight that you can switch on. I wonder whether that's just a brightness control for that. We've got a lovely arrangement in here for locking the telescope part. Runs down onto, we've got a locking ring here, a little transfer drive here going onto a stainless steel belt down onto a mechanism in here, which is activated by this locking knob. So that's unlocked, and then when you lock it, it closes a clutch up in here, which then moves against this arm here and provides the spring-loaded preload onto it, so it doesn't rattle around. Takes all the play out. Really nice. That is so cool. Right, so that's the keypad and display, all nicely mounted in a metal enclosure, which just passes through to the other side there. I'm guessing that's going to be well environmentally sealed, but doesn't appear to disconnect easily. We've got a little access panel in here. I'm presuming, actually, was that a bit of grass? I presume that the same optical arrangement we have up in the top here, this bit here, there must be another one to do the horizontal axis. So let's just take off this here and see what's behind here. Nothing. Oh yeah, there is actually. Oh, this is the a similar sort of locking arrangement that we saw for the vertical axis. So that locks, and then you've got the spring preload. Right, I've just reattached that because it was just flapping around. I've just discovered that you can remove the base, which has the level adjustment knobs on. I think it's called a tri-back. There's just a knob on here, and you just flick that round, and it unlocks, and that comes off in one. So I've got another level there. So yeah, we've just got a locking mechanism there, and we can see the optical plumb down the centre, which you look through for there. This is all on a nice bearing. Right, it's just been a couple of days because I had to pause the teardown and do some other things. And I actually also was trying to figure out how this base part comes off, because it didn't seem particularly obvious how this comes away. Now, after a little bit of looking around, I found a couple of little access ports. There was one here and one just here, and I needed to make a little tool to get those out. So that's been done, and that has revealed a hole here. Now, if you turn this round to a certain point, holding this out a bit still, you'll find there is a hole, and that does give you access to a set of 7 screws deep inside, which allows this to come away. So what I'm going to do is just finish out taking out those screws. We'll get the base off, and we'll see what it's like inside here. Let's attach the base again. And this should lift off. Right, just looking up into the base, we've got the back of the keypad there. We've got a prism arrangement for the eyepiece, so that just travels through here. It looks like there's some kind of focusing adjustment, travels through, and then there's a little mirror prism thing there, just to reflect the light downwards and through the centre of the base unit there. Not much else going on in there. Those will be the wires for the battery, and these just transfer the wires up into that top section. So let's just put this out the way. Oh, what is that? Not entirely sure what that is. We've got 2 wires and a hole, possibly the beeper. That might be the piezo beeper. Okay, let's have a quick look at the base in a bit more detail. We've got wow, beautifully machined bit of metal there. It's almost polished. Well, yeah, it has been ground and polished. That is absolutely, it's like glass. So we've got a similar arrangement to what we had up at the top. We've got a glass disc with an encoder on it, driven by a motor. We have optical sensors on this side, and there is actually some on the what would be the fixed part in the centre. So I think what we have is one glass disc on the top with a grating in it, which is on the part that moves, which is also driven by the motor, and there is a second disc underneath which is fixed to the base. Now, one thing I've noticed is there's no sensors shining through this top disc, so I think they're reflecting the light off it rather than passing through. I guess that might mean they can make it shallower. You don't need anything on top to point down. You can just reflect off the probably metallized coating that's on the actual glass disc. Now, it took me a little bit of thinking to realise why we actually have a motorised wheel on here. And of course, if this is set up, the base unit is fixed and it's all locked off into a position, then the grating isn't going to move. And if it's not moving, then you can't measure anything. So what they're doing here, they've got a motor to spin the grating to actually allow you to take a reading while the unit is actually fixed in a position. So roughly how these optical encoders work is it's a set of two gratings, and as they mesh together they create an interference pattern, and then you can just sense that, and that allows you to take very, very fine, accurate readings of the position of the one grating against the other. Especially as if you look on this this disc here, there is actually some index marks, one there and one over the back there. So not only will this be measuring the pulses of light reflected off this disc, it will also be looking for those index pulses as well to find its position. So there's some really nice little bits of engineering around on here on the sensor arrangement. Obviously this is going to need to be set up, calibrated and aligned very precisely, and you can see there's lots of gunk on these screws to set them in place. There's a little driver board here, probably with an op amp on, which will provide enough power to run up the cables to the actual processing board. There's two devices on each side, one there and one there, so presumably one is probably an infrared transmitter and one is some kind of optical pickup. And the same on this side, and I would imagine we've got a similar setup on the inside for the fixed disc. Oh, see, so that's a little retention piece. Oh, and that I see, that is part of the alignment. There's a couple of set screws in there, and that allows this to rotate. So presumably you can align this up so it gets it bang on 90 degrees on those grating, on the grating that's on the disc. So a little rotational adjustment there. I think I'm probably going to have to take off the glass disc. There we go. Wow, doesn't that look beautiful? Yeah, you can just about see the grating markings on there on a nice glass disc. Wow, that looks amazing. Beautiful bit of engineering on there. Okay, let's right, so we can see the lower disc. Oh, there's no gratings on that actually. Oh no, there is. It's yeah, it's just a single slit. Sorry, there's just a single slit on that section and one on there that goes through to the optical sensor, and there's a similar arrangement on this pickup, which was on the moving part of the grating. So this should come off now. So yes. That is the motor in a lovely little metal cage and a set screw. Right, I think I'm going to have to admit defeat on this one. I suspect what needs to happen is two bearings need to get pulled apart. I probably don't really have the ability to do that right here. So yeah, but from what I can see, there's what looks to be a PCB down in there. Not sure what it's for, but there's a whole bunch of wires going to it. Right, well, what I can see in there is there seems to be an encoder disc with some wipe contacts on. I can just see the contacts touching on a disc with different tracks on, a bit like a multimeter selection wheel thing. So maybe what they're doing on that is reading quadrants, so it knows what quadrant it might be in. So we've got an optical encoder wheel just like we saw before. This time though we have sensors going through the disc. You can see here the sensor is actually shining through the encoder disc, which is kind of interesting. We've got the slip ring assembly, which passes the connections through to the eyepiece. So we have what looks like an LED, or maybe a infrared LED that shines through the disc onto possibly a prism, and then there's another prism. So I think what it's doing is going down through the disc, then down, and then bouncing up into this assembly up here, and then there's some optical stuff going on here. So the sensors are actually in a completely different location than we saw on the base, up in this arrangement here. Right, so let's take off the slip ring assembly. Right, so I think I'm going to take out the sensor, because it means I can get rid of all this wire. Right, well that is another grating slit just in there. See if I can get you a better view. Should just be able to see a mirrored surface there. Tiny, tiny little slit. So there's some crazy optics going on in here. Right, I think I will remove the glass disc now, like we did before. Is the second encoder disc, and you can just see in here the arrangement that I was talking about before. So I think there's a mirror prism arrangement here, which bounces the beam up into here, up into this unit. Right, there we go. We can see the movable part, and of course we had the encoded disc on top of that, the one that is operated by the motor. So I can just turn that around while we turn the eyepiece. Now I'm thinking, looks like the whole of this is on a base plate of some description. Wonder if it's that magic stuff Amulite again, but it does look like I might be able to take out the whole thing if it comes past the glass disc. So let's give that a try. So that is pretty much as far as we can go on that one. Again, I have no idea how the this assembly comes off this part as well. Looks identical to the other one. I guess under there is a pretty big bearing. So we can see the sort of main optical part now. So it looks like we've got the two beams coming up here, and I guess it gets combined and something happens in here. Let's just take off the top, see what it is. So we've got some optical paths coming up here, and then they go out to the sensors there. So there's a couple of lenses in there I can see. I don't think I've got much hope in actually figuring out exactly how this is working, but it's very cool to see. Then we've got this weird thing. Oh, it's cut off. Sake. Right, okay, yeah. That's a mess. It's some kind of oil. Ah! Right, I've just had a clear up. So yeah, fluid optics, who knew? Yeah, but I'm not sure what is actually going on here. Now, interestingly, there is actually a piece of glass in here, and there's actually still fluid underneath this, and there is a little spike in the centre of this. So I wonder, when this is screwed together, this will slightly distort this glass and create some kind of optical effect. What that exactly is, I have no idea, and why you would need the fluid. Yeah, there's definitely some optical voodoo going on. So I'm just going to try and get out this little ring. So just a aluminium ring with some knurling on the outside. Right, that's the last of that oil cleared up. So we have this ring, and the glass fits inside there, then sat that way up, went down, hit that mirror into this prism, so it's down, then across, up through here. There's another mirror in here which then comes out to here, that then travels up into this bit here, and then comes into one of the ports on here, and we also have the output going to this sensor here with a grating slit in it. So yeah, I'm not sure whether I'm going to be able to figure out what exactly is going on here, because there's a whole bunch of voodoo going on. I think it's going to be quite a complex one to try and figure out. But suffice to say, it's stupidly complicated and amazingly engineered. What a beautiful thing. Shame I took it apart, really, isn't it? But there we go. Who knew that something this complicated would be inside? Now, this is one of the other sensor modules. So we've got, I'm not sure which one, that one's 2-pin, that one's 3, so probably that's the transmitter and that's the detector. Interestingly, they're offset at different angles there, so there must be some mirrors and stuff going on in here. The little grating slit. Optical trickery going on there. I'm not quite sure what's happening there. Okay, let's have a look at the keyboard and display assembly. It's got some weight to it, this, I tell you. It's obviously made all out of probably aluminium, cast aluminium. Right, so we've got some really cute little LCD display units there. We've got the back of the keyboard with semi sort of flat flex kind of thing going down onto the circuit board. We have an NEC device in there, a D8741AD. I suspect that is one of those EEPROM microcontrollers. So it's basically a UV erasable microcontroller, and it's in a socket as well, which is nice, so that can go into my ceramics collection. Yes, that indeed is a Swiss-made precision motor e-scap. Do a Google for that and I found a website called Portascap, which is a Swiss motor manufacturer. Can't quite see the model number, it seems to be so faded. I can't really see what it is. Swiss made, 4.85. Yeah, that'll be a beautiful precision motor, that. Right, well, I think that is pretty much it. Not really much more to see now or discover. So I hope you enjoyed this one. I did. If you'd asked me whether this was going to be an interesting one when I bought this, I probably would have said no, it might be a bit dull and boring, but wow, there's just so much stuff in here, it's crazy. And the level of engineering is quite remarkable. I mean, the whole optical stuff is just like, there's just a whole bunch of voodoo going on there, and yeah. So I hope you all enjoyed this one as much as I did. So thank you very much. Thanks to all my patrons who help pay for this kind of thing to be taken to bits. And thank you for all the support. If you like this video, give it a thumbs up. Comments, if you've spotted something in here that I've missed or something that I've got wrong, mention it in the comments, and I'll be interested to know what you've got to say. So thanks very much for watching, and I'll see you on the next video. Bye for now.